download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about chemical equations. So chemical equations show chemical reactions, and here you're seeing two types of chemical equations. You're seeing a word equation and a symbol equation. In both of these types of equations, the reactants are on the left. So these are the things that we are reacting together, and the products are on the right. The products are what's formed. So in this example, hydrogen plus oxygen makes water. The symbol equation shows the atoms involved on both sides and the amount of atoms that are involved on both sides. So we can see here that 2 hydrogen atoms bond with 2 oxygen atoms to make H2O. Okay, now there's a bit of an issue with this symbol equation because symbol equations need to be balanced. By that I mean there must always be the same number of atoms on both sides. They can't just disappear, and that's because of something called the conservation of mass. The mass before the reaction takes place is always the same as the mass after the reaction takes place. That means there must be the same amount of atoms before as after. And in this example here we see 2 hydrogen atoms first in the reactants and 2 oxygen atoms in the reactants, which are here. And on the right hand side, the products, again we can see 2 hydrogen atoms, so that's fine, but we can only see 1 oxygen atom. So we need to be able to learn how to balance this equation out to make it right. So I'm going to talk to you how to do that now. So as I just said, symbol equations need to be balanced. So let's balance this equation here. So I'm just going to write it out bigger. And I always suggest you doing that in your exams as well to make sure you have something to work off of. Okay, so sodium plus chlorine makes sodium chloride. Okay, so the first thing we need to do is check that whether it's balanced or not. And to do that, we need to count up the atoms on both sides. So what we're going to do is just underneath here, underneath this equation, to make it easier for you, we're going to rewrite out the atoms. So there's 1 sodium, because there's no number after sodium, so we're going to write that there. There's 2 chlorine, so what we're going to do is we're going to write Cl, Cl, to show that there are 2 chlorines. And then on this side, we've got Na to show 1 sodium, and Cl to show 1 chlorine. Now we cannot mess with those numbers, and what that means is this little number here we cannot mess with. So to show that we can't do that, what I'm going to do is I'm going to circle these numbers here. I'll circle these elements to show that we cannot add any numbers to that. We cannot change this little 2. So now let's count what we've got. So Na on the left, we've got 1. And Cl on the right, on the left, sorry, we've got 2. So 2 there and 1 sodium there. Whereas on the product side, we've got 1 sodium and we've got 1 chlorine. So we need to ask ourselves, are they balanced? No, they're not. There's an uneven amount of chlorines. So what can we do? Okay, now this is why I suggest you circle them, because what we can't do is we can't put a 2 here. Okay, we can't just suddenly make 2 chlorines appear here. It doesn't work. We can't do that. Okay, so that does not work. So we can cross that out. The only thing we can do is add numbers to the front of our different atoms and compounds and elements and compounds. Okay, so we need 2 chlorines. So the only thing we can do is double this number, this sodium chloride here. So we're going to have a go at doing that. So what that gives us is another Na and another Cl. And we're going to circle that as well to show that we can't change that. So now we can recount up our atoms on both sides. So how many Nas has that now given us? 2. How many Cls has that given us? 2. Are they now balanced? Well, the chlorines are now balanced, but the sodiums are not balanced. Now we've got 2 sodiums. So we need to go back over to the other side and try and balance out the sodium. So here we can see that I can't put another Na in there. I can't just make another Na. I can't just put a little 2 next to the Na. So I'm going to put a big 2 here. And that now gives us another Na underneath that we're going to circle. So that changes 1 to 2, and now they're balanced. So let's write that out as we would. That means we've got 2, which comes from there, Na, plus Cl2, which we've not changed, makes 2, which we've come from there, NaCl. And that is now a balanced simple equation. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. Let's try another one. So K, which is potassium plus water. It's potassium hydroxide, KOH plus H2. So let's now write out what we've got. So we've got 1K, we've got 2 H's and an O, we've got a K, an O and a H, and we've got 2 H's, H2. We're going to circle all of those to show that we cannot change anything there. And that's now count out what we've got. So K equals 1. H equals 2 and O equals 1. On this side, K, there's 1. O, there's 1. H we'll do next because we'll put them the same, both sides. H is 3 and O is 1. So you can see here we've got 1 potassium on both sides. They're balanced, but the hydrogens aren't balanced. So we've got 2 here and we've got 3 here. So we need to somehow get closer to 3 there. Now, actually, we can't go from 2 to 3 unless we times it by a half, which we can't do that at 1.5. So because we need to times it by a whole number, so we can't just do that. So we need to then make up a number that's higher than 3. So let's try and put in 2 in front of here. What does that now give us? Well, that now gives us 2 oxygen, but it gives us, so there's another one there, like that. So it gives us 2 oxygen, but now it gives us 4 hydrogens, and we've still got 1 potassium. So now we've got to go from 3 hydrogens to 4. So how are we going to do that? Well, if I doubled this one here, that would give us 5, which would be too many. So if I tried to maybe double this one, because there's only 1 hydrogen here, that would now give us 4 hydrogens. So let me try and do that. Let me double this one. So K, O and H. I've got 2 of them. So that now gives us 2 potassium. It now gives us 2 oxygen. And it now gives us 4 hydrogen. And so again, the hydrogen is now balanced, the oxygen is now balanced, but the potassium is now not balanced. So we need to go back over to the left, because we've got 2 potassium on the right, but 1 on the left. So we can't interfere with any of the big numbers, so maybe we can just give another potassium there, and that now gives us 2. So now we can count up what we've got. So we've got 2 lots of K, so we're going to write 2K, plus 2 lots of H2O, so 2 H2O, an arrow, we've got 2 lots of KOH, so 2 KOH, plus, we've still only got 1 lot of H2, we haven't altered that, so H2, and that is now balanced. We'll do one more together, and then I'm going to give you a few to get on with on your own. So here we've got MgCO3 plus Ca, so CaCO3 plus Mg. So let's write them out like we've done before. So Mg, there's 1 Mg, 1 C, and 3 lots of O's. I'm going to circle that. So there's 1 calcium, there's 1 Ca, 1 carbon, don't get confused between the carbon and the Ca, and 3 oxygens here, and then 1 Mg here. So that gives 1 magnesium on that side, That gives 1 carbon on that side. Again, don't get confused with the Ca and the C. It gives 3 oxygen on that side, and it gives 1 calcium on that side. Now this side, now we've got 1 calcium. We'll do it in order actually. Make sure you always do it in order, so the same order that you've done on the left. So Mg is 1 there. There's 1 carbon. There's 3 oxygens. And there's 1 calcium. Now, are they balanced? Well, actually, yes, they are balanced, so you don't need to change that. So that is already a balanced equation. So now what I'd like you to do is have a go at these questions. So you've got 2 questions there to answer, and then 4 balance and practice questions, and then we'll go through the answers together to make sure you understand. So pause the video now. Okay, so let's run through the answers then. So number 1, where do you find the reactants on a chemical equation? Well, you find the reactants on the left. Where do you find the products on a chemical equation? Where you find the products on the right. Okay, so now I'm going to quickly go through the first 3 balance in one. So I've already done the answers for you here. So for question 3, you should have got P4 plus 5O2. Makes 2P2O5. For the next one, you should have got 4Al plus 3Cl2 goes to 2Al2Cl3. And for the third balancing equation, you got 3S plus 3F2 makes 3SF6. And if you got any of those wrong, then what I would suggest doing is to contact one of our tutors, and they will guide you in a direction as to where you might have gone wrong. But we'll go through this 4th one together because it might be a little bit more difficult. So let's go through the answer to this. So underneath, we're going to write out what we've got. So Mg. Now, that little 2 after that bracket means there are 2 lots of everything in the bracket. Okay, so that actually means we've got OH, OH. 2 lots of everything in the bracket, and then we're going to circle that to know that we can't change it, plus K makes KOH, can't change that, plus Mg. Okay, so what have we got then? Mg on the left is 1, oxygen on the left is 2, hydrogen on the left is 2, potassium on the left is 1, and the other side we've got magnesium is 1, oxygen is only 1, hydrogen is 1 there, and potassium is also 1. So what isn't balanced? Magnesium is balanced, hydrogen isn't balanced, and oxygen isn't balanced. So on this side here, the right side, we need to add more hydrogen or oxygen, and the way we can do that is if we get another KOH in, because that contains both hydrogen and oxygen. So underneath, we'll do another KOH and give that a circle. So that now leaves 2 potassium, we've got 2 hydrogens, and we've got 2 oxygen. Now the oxygen and the hydrogens are now balanced, but you'll see that we've now unbalanced the potassium. So there's 2 on the right and 2 on the left. So we need to now go to the left to try and balance them. So we need to balance, we need 2 lots of K. Well, we can see here that there's 1 lot of K on its own. So it's very easy just to then do another K, and that then gives you 2. So what you should have got, therefore, as your answer is MgOH2 plus 2 lots of K. Okay, now these should be on the same line, but I've run out of room to make K2, so 1, 2 KOH, plus we've not changed the Mg, so 1 Mg. So Mg brackets OH close brackets 2 plus 2K goes to 2 KOH plus Mg, and that is your balanced equation. Now, balancing equation is one of the trickier topics that people tend to find quite difficult in chemistry, and you need to make sure you can get it right. So if you don't understand or if you've got anything wrong, then please, if you're a paying member, get into contact with one of our tutors and we can guide you through where you're going wrong. Now though, if you do understand it, you can move on to the quiz and you can move on to the exam questions with plenty of practice to keep and making sure you still understand it all the time. But as I just said, if you don't understand anything, please get into contact with one of our tutors and we'll be happy to help.